about antiderivatives and integration. And if you did watch the video, you certainly saw the little table there with the antiderivative rules and how they correspond with the derivative rules, and how, in essence, it's basically the reverse of derivatives, right? An antiderivative. And so I've got some practice questions here for us to look at. So here we go. Number one is full of good stuff. It's full of some things I'm going to highlight for you that some people will struggle with, not because they don't know calculus, but because they're maybe a little bit careless with algebra. So I'm going to do a little rewrite here for number one. Number one, I would rewrite this as the integral of 5x. But then this next one, I would rewrite it because I don't want it to be that fraction. We'll avoid fractions for as long as we can. Eventually, we've got to deal with them. How would you rewrite that? You'd be surprised how many times I see perfectly good math students rewrite that as like x to the 1/4. Treat it almost like it's a radical, but it's just x to the negative 4. The next one is a radical, right? So it's going to be minus x to the 1/2. And then I'll just leave that plus 2 sine of x as is. And then perhaps you remember that the antiderivative of a sum or difference basically equates to you just go term by term by term. That is not true of multiplication, right? Not true at all of multiplication. But if it's sum or difference, you just go term by term. So this first term would end up being 5/2 x squared. And to get that, I'm just using the power rule for antiderivatives, which is the reverse of the power rule for derivatives. Instead of bringing the old exponent down and subtracting 1, I add 1 to the old exponent. Then I take that new exponent and divide by it. It's just the reverse. Similar idea with the power rule on the next one. Anybody have an idea what that next antiderivative would be? Yeah, negative 1/3 x to the negative 3. That's right. Okay, the next one, sometimes a little bit tricky. What's the exponent going to be? What's the exponent going to be? 3/2. Yep, you add 1 to the old exponent, so it's going to be x to the 3/2. But then the new coefficient will be 2/3, right? Technically, it's divided by 3/2, but I usually just do a mental copy dot flop, and instead of dividing by 3/2, I'll write times 2/3. Yes, I said copy dot flop in a calculus class. I did. So plus 2 sine of x, what is the antiderivative of sine? Negative cosine, so yeah, negative 2 cosine, right. So negative 2 cosine of x. And then don't forget the plus c. Talked about that a little bit in the video, I believe. The plus c just stands for any potential constant. Later on, of course, we'll have information where we could maybe find what that c would be, given a differential equation, but for now we're just finding an antiderivative. Any questions there? Sometimes number 2 is tricky. What is the integrand on number 2? 1. That's right. So this is the antiderivative of 1 dx, or you could really just say the integrand is dx. I mean, that's not inaccurate at all. But this might help a little bit when you think, all right, well, what can I think of that if you find its derivative, you get 1, and the answer is x. Yeah. So the answer to this would be x, and then don't forget the plus c. The plus c is always worth something. If you neglect the plus c, it'll always come back to get you in some way or another. Colin?
Is minus c also derivative?
Yeah, technically you could put minus c. I mean, the custom is certainly plus c, but it'd be hard to argue with minus c. As long as you're consistent, you're good. What's that? You will lose style points in my heart, but not on your test. Yeah, there's really no argument that it has to be plus c. You could put minus c. Just flip everything around. I think it's okay. Hey, number 3 is probably the most frustratingly missed based on an algebra goof. Let me show you what I see all the time. I see something like this. People recognize, hey, it's a fraction. I need to do some moving around, some algebra. And they'll do this. Carefully, please, watch. What's wrong with that? It has to be a negative exponent, doesn't it? So you're doing two things, right? You're converting a radical over to a rational exponent. But also you're flipping up to the top. And whenever you move levels like that with a fraction, then you've got to change the sign on the exponent. So that's one kind of a tricky little step there that sometimes will trip people up. Bless you. But now there's another one. I mentioned this earlier. If you have the antiderivative of a sum or a difference, you just go term by term, like we did with number 1. Number 3, it's tempting to be like, oh, it's just the antiderivative of a product. And you'll find, if you don't remember already, that the antiderivative of a product is much more complicated than the antiderivative of a sum or difference. You can't just be like, hey, the antiderivative of x plus 1 is this, and do the other one, and we're good. You can't do it that way. So instead of doing something we'll learn later, which is called integration by parts, or maybe a chain rule thing, what should I do here? I'm not going to do U substitution. She got the rainbows going. Distributive property. Yes. You got to do the distributive I guess you don't have to, but that's going to be the best way to go. So it would be the antiderivative of x to the positive 1/2. Because remember, if you multiply your bases, you add your exponents. And then plus x to the negative 1/2 dx. So then when you find your antiderivative, now it is simply a couple of power rules. So the antiderivative of x to the 1/2, we already did that. That's 2/3 x to the 3/2. But then how about the other one? What is the antiderivative of x to the negative 1/2? 2x, positive 2x, right? Yeah, so it'd be plus 2x to the 1/2. And then please don't forget your c, plus c. This does take some adjusting. We've been doing derivatives so far this year, and this is antiderivatives. Obviously it's different. Okay, I think we'll do one more here. We'll see. All right, so number 4. Do I want to do number 4? We have like a minute and a half left, or less than. We're done at 25, am I right? Okay. Let's do number 4. That's fine. We'll live right on the edge. That's right. So I chose to do this one because this one has a little bit of a trick to this. It is a fraction, and we don't really like fractions. If we use a little bit of trig facts, we can do some stuff with tangent. You're right. What if we rewrote it like this? So this has a little bit of a trick to it, right? This is one of those things you just got to see it. And if you don't see it, it's going to be really, really hard to do. So anyways, you could do this with a chain rule thing as well. What is sine over cosine? And what's 1 over cosine? So the point of this, perhaps, is, do you remember that little quick rule guide that you saw? What's the antiderivative of secant times tangent? Secant, right? So this would be secant of x plus c. So guys, there is a 4.2 video. We'll probably run through this pretty quickly tomorrow. We'll catch these last few examples. We'll be into 4.2 when we get tomorrow. All right. Have a great rest of your day. See you tomorrow.